Hey, welcome back. Today we're going to learn how to machine this bottle opener here with Autodesk HSM. Let's go ahead and get started. So the first thing you want to do is click up here on the Cam tab, and we're going to start, as always, a new setup. Now we want to go ahead and set up our work coordinate system, which allows our machine to reference the part. Okay, so we're going to go ahead now and click this back corner box here. So basically, you need to make sure that your X, Y, and Z coordinates are set up correctly. And in this case, they are already set up for us. Our X, our positive X should, if we're facing the part, our positive X should always be pointed to the right. Our positive Y should always be pointed away from us. All right. And our Z, our positive Z should always be pointing upwards. Okay. So now let's go ahead and set up our stock material here. We're going to want to do a fixed size box. And for X, okay, we want to go ahead and use 4 inches, and we're going to want to center it here. And for our depth, we're going to want to go ahead and do 1.5 inches, and once again, make sure it's centered. And then for our height, for our Z, all right, we want to give it a thickness of 0.075 inches, and we're going to offset that from our positive Z axis, the top of it, okay, a distance of 0.01 inches here. Okay, everything else looks good. Let's go ahead and hit OK. Now, the first thing we want to do with any machining operation is to create a perfectly flat part. So to do that, we're going to do a facing operation here. And we got to select our tool. And for our tool, you want to go ahead now and reference your bottle opener tool library here. And you're going to want to do the 3-inch face. Okay, and go ahead now and hit select. Coolant, for this one, it's a single pass, so we're just going to leave it disabled. We're going to go ahead now and use a spindle speed of 5,000 and a cutting feed rate of 40. All right. And now for our geometry here, we're going to go ahead now and select the top of our part. We're going to select this circle right here, and we're going to select this guy right here. Now be careful, don't select down here because that'll take that off. You want to make sure you select the top of your part. Okay. And all of our other default values are fine. Okay, and so we're good to go. Let's go ahead now and hit OK. And you should end up with the following toolpath here. Now we need to remove the material around the outside perimeter of our part or bottle opener here, and we want to use a 2D adaptive to do that. We're going to change our tool now. In our bottle opener library, we're going to select a 1/4 inch flat end mill. Okay, tool number 4. Let's go ahead and hit select. We're going to set our coolant to flood. We're going to use a spindle speed of 5,500 RPMs and a cutting feed rate. Since this is a roughing operation, we're going to keep the speed or the feed rate a little higher. We're going to go with 50. Okay. And now for the geometry, we want to go ahead now and select the outside perimeter of the part, this guy right here. Okay. And now for our tabs, you'll notice that by selecting here, okay, by selecting this height, it's only going to cut that deep. We need to fix that. So we're going to go to the heights tab now, and we're going to set the bottom height to model bottom here. Okay. And that will make sure it cuts all the way down to the correct depth. For our passes tab now, we're going to use an optimal load of 0.08 inches. Okay. And for, let's see here, stock to leave, we want, since this is a roughing operation, we want to leave a little bit of stock behind. For radial stock, we're going to use the default value here of 0.02, but for our axial stock, we're going to go all the way to the bottom of our part, and we're going to set that to 0. We're going to go ahead and check smoothing, and for feed optimization, we're going to check that too, so it slows a little bit down in the corners here, so our tool doesn't overheat. So and we're going to uncheck only inner corners. All right. Should be good to go. Let's go ahead now and hit OK. And if you did everything right, hopefully you got this tool path here. Our next step is to basically remove material within the interior of our part here, our pocket, our mouth area, and our hole here. So to do that, we're going to come on up here now, and we're going to use what's called a 3D adaptive milling operation. And what this will do is it will detect everywhere that basically needs to be machined and create a tool path for that. Once again, we're going to go ahead and stick with our 1/4 inch flat end mill, tool number 4. Make sure our coolant is flood, all right? And we're going to use a spindle speed, the same as last time, 5,500. And then we are going to use a feed rate, once again, of 50 inches per minute. Okay, now for our geometry tab, okay, we basically we're going to check stock contours here. And we're basically going to just check the bottom here of our part, kind of like what we did last time. Oh, and before we do that, let's uncheck rest machining so we don't create more tool paths than necessary. And we're just going to check, once again, this guy right here. Okay. For the passes tab here, once again, let's use an optimal load of 0.08. And then down here, we're going to use a maximum roughing step down of 0.5 inches. And then since, once again, this is a roughing operation, we're going to go ahead and leave a radial stock to leave of 0.02 and an axial stock to leave of 0.02. Go ahead now and just check smoothing and feed optimization, and we're going to use those default values. In the linking tab over here, we're going to scroll on down and make sure our ramp type says helix, and we're going to use a ramp angle of 3 degrees. Okay, go ahead and select OK. And hopefully, if you did everything right, you got the following tool paths here. All right, so we're pretty much done with all of our roughing operations. Now we want to go ahead and remove the material that we left behind in these roughing operations. So the first thing we want to do is go ahead up here and we're going to do a 2D contour operation. And we're going to go ahead now and use the same tool, a 1/4 inch flat end mill, tool number 4. We're going to set our coolant to flood. All right, but as you probably already know, finishing passes are done with slower RPMs and feed rates. So we're going to use a spindle speed here of 3,000 and a cutting feed rate of 30. All right. And now for our geometry here, we're going to flip our part over. And once again, we're going to select the perimeter of our part and the inner diameter of our hole here. Okay. And then for our passes tab, we're going to do the same thing we did last time, if you recall. We're going to use the model bottom as our height, but we're actually going to go a little bit deeper now. We're going to use a bottom offset of 0.01, and I should emphasize this, a minus, because we want to go a little bit deeper than our part. Okay, and we do this because when we go to face off the material along the bottom of our part in another setup, this will give us a nice clean separation when we go to face it off. All right. All right, all of our other default values are okay. Let's go ahead now and hit OK. And if you did everything right, you should end up with the following toolpath. And if you look here, our toolpath should be just slightly below our part. Okay, and that's what you need. Okay. Moving along with our finishing operation, now we need to remove the material here in the mouth portion of our the stock that's left behind from our roughing operation here in the mouth portion of our bottle opener. And to do that, we're going to do yet another 2D contour toolpath, and we're going to use tool number 4, a 1/4 inch flat end mill, set our coolant to flood. We're going to use the same spindle speed as before, 3,000 RPMs. Since this is a finishing operation, we're going to slow our feed rate down and we're going to use 30 inches per minute. Okay. Now for our geometry selections here, it gets a little tricky. So I'm going to zoom in. I'm going to select this guy, make sure it's blue, and then I'm going to select this line right here. All right. And then I'm going to check stock contours and I'm going to check this guy again. All right. And now for um, our heights tab, we're going to come on down here and we're going to do selection and we're going to select this flat portion. I'm going to move my mouse around here, so right here. So we want to select that guy. So our tool will come down and select, get this area in here. And then we're going to come over to our passes tab now. And right here, we're going to select multiple finishing passes and we're going to set the number of finishing passes here to 3. And we're going to set our step over here to 0.2. Okay, very important. I think that about does it. Let's go ahead and hit OK. And if you did everything right, you should end up with a toolpath that looks like this. Now, do me a favor, click on your first setup and run your simulation. Make sure you check on stock, okay? And make sure you check on stop on collision, okay? Go ahead and run your simulation and double and triple check it. And when you're ready, come on back to this video and we'll move on with our finishing operations. All right, so now we want to go ahead and continue with our finishing operations, and we're going to do another 2D contour operation. And now we need to remove the stock that's left behind in our pocket here along the walls and along the bottom. So once again, we're going to select our tool number 4, 1/4" flat end mill. Our coolant's going to be flood. Our spindle speed, since it is a finishing pass, is going to be 3,000 RPMs, and our feed rate once again is 30. Now for our geometry, we're going to select the inside pocket of our part here. All right, and we're going to basically now, over here in passes, we're going to use multiple finishing passes. We're going to set that number to 2, and we're going to use a step over of 0.2 inches. All right, and that should do it. Just go ahead now and hit OK, and you should get a toolpath that looks like this. We still have stock that's left behind on this portion of our bottle opener here that we need to remove. So to do that, we're going to do yet another 2D contour operation. And once again, same tool as before, our 1/4" flat end mill, coolant sent to flood, our spindle speed is 3,000, and our cutting feed rate is 30. All right, now for our geometry, it's a little tricky here. So first we're going to select this guy, and we're going to select that guy over there. And now we're going to go ahead and check stock contours, and we're going to just kind of make sure this part is highlighted. All right. Now we're basically good for geometry. Let's come on over here to passes, and we're going to check multiple finishing passes, and we're going to do 5 of them. And this time we're going to use a step over of not 0.2 but 0.24 inches. All right, and that should do it. Let's go ahead now and hit OK. And if you did everything correctly, okay, you should end up with the following toolpath. Now we need to make these fillets on both sides of our part here. All right, and to do this, we're going to use yet another 2D contour, but we're going to change our tool now. Okay, we're going to select our tool here. So click Tool, and under our bottle opener tool library now, we want to select our 1/4" ball end mill, which will give us the nice round surface of our fillet that we desire. So go ahead now and hit select. Select, make sure our coolant is to flood. And once again, we're going to use a spindle speed of 3,000 and a feed rate now of 30. Okay. And for geometry, the first thing we're going to want to do is to use a tangential extension distance of 0.015 inches, which will tell our tool to wrap around a little bit longer around our circle here. And then we're going to basically check the blue lines along the top of our fillet here. So that blue line, I'm going to move my part around here with that blue line. And then we're going to come over here and check stock contours. And we're just going to, this is a little tricky. Nope. There we go. And right there. Okay, that's the geometry that you want. All right, so it may take you a second, but that's the geometry that you need to get. Okay, now in the heights tab, this is important. All right, on the bottom height here, we're going to do selection, and we're going to select that surface here. Okay, let's go ahead now and select OK. And if you did everything right, you should end up with the following toolpath. Okay, and do me a favor, once again, run a simulation, make sure that you have your ball end mill comes through here and creates these nice round fillets that you see here. So our finishing operations are pretty much done. Now it's time to start adding these chamfers that you see all throughout the part here. So to do this, our first chamfer is going to use a unique operation called a 3D scallop operation. Okay, and our tool is actually going to be a 1/4 inch ball end mill. Most of the time it'll be a chamfer tool, but in this case, we're going to make our chamfers here with a 1/4 inch ball end mill, the same tool we used in our previous operation. We're going to set our coolant to flood here. And once again, we're going to use a spindle speed here of 3000 and a feed rate of 30 inches per minute. Okay. Now for our geometry tab, it's going to start getting a little tricky here. So please listen carefully. So as best you can, zoom in here. And we're just going to click on these green lines, and it may take you a couple tries here, and that's okay. So the green chamfers, I should say, will be outlined green. All right, and don't worry about these little triangle parts at the end. All right. Now do me a favor. First thing you're going to do here now is over here, check contact point boundary, please. And we're going to enter an additional offset here of minus 0.000. That's 3 zeros after the decimal point, and then 25 inches. And we're going to use a boundary overlap here of 0 inches. Okay. Now for our passes tab, we're going to check down here where it says limit number of stepovers, and we're going to limit the number of stepovers to 1, okay, the default value, and we're going to set our stepover value here to not 0.125, but 0.0125, okay? Go ahead and select OK. And if you did everything right, you should end up with the following toolpath, all right? And it's kind of a 3D sort of chamfer we're adding here. When you think about it, our chamfers aren't just in an XY plane or a Y plane. They're in they cross over into the X and Y plane. So do me a favor, same thing. Please simulate this. Pause this video and simulate it. And when you're ready, come on back so we can continue on here. Now we need to continue making our chamfers, and there's multiple ways to make chamfers. As you just saw, we used a 3D scallop here to make these side chamfers here, but now we're going to use not a 2D chamfer operation, but we're going to use a 2D contour operation to make our chamfers because I feel like it's a little more user friendly in this case. So let's go ahead now and select 2D contour, and we're not going to use our ball end mill anymore. We're going to come over here and we're going to come to our bottle opener library, and we're going to select our 1/4 inch 45-degree chamfer end mill. Here, let's go ahead and select that guy. Make sure flood is on, and we're going to use a spindle speed of 3000 again. So 3000 and a cutting feed rate of 30 inches per minute. Okay. And for our geometry now, we're going to make sure we check not the top of our chamfer edge, but the bottom of our chamfer edge here. And we're going to do the same for that one and the same for this guy. And then we're going to come on over here to our mouth portion, and we got to add this chamfer that goes around it. And if you notice, when you go to do it, it wants to do the whole thing, and we don't want that. So go ahead and click on it, and then double click on it, and this is going to pop up. And we need to create sort of a custom toolpath here. So we're going to click there. And if you notice, that blue line's already highlighted, so we're going to click along that edge. We're going to click that guy, move our part around here, that guy, and that guy. And we need to make sure it's all goes all the way around. It looks good. Actually, it doesn't. We need to get this guy right there. And now we're good. Go ahead and hit the green check mark. And that's what we want for our geometry. So a little tricky on that geometry, but you can get it. If you mess up, just hit that red X and start over again. In our passes tab, all right, let's see here. We want to come down, oh, here it is. Check chamfer box now, and we need to make a chamfer tip offset to 0.03 inches. And I'll show you what that will do here in a second, okay? And you need to do this so you don't get burrs on your part. Very important. So if you look at it right here, what that will do is it'll move our tip, the tip of our chamfer tool, just down 0.03 inches down past the edge of our chamfer. So that should do it. Go ahead now and hit OK. And I'm going to show you guys real quick with the simulation what that will do here. So I'm going to go ahead and just simulate this guy. I'm going to take off stock here and just zoom in here. And if you look, okay, what that does is it moves that chamfer tip offset. It moves the tip of our chamfer tool 0.03 inches down below our chamfer here. So we get a nice clean chamfer with no sharp edges, okay, or burrs. All right, so I'm gonna go ahead now and hit close. Now for the final chamfer of this setup, we need to make this large chamfer right here. Okay, and that's kind of like the lip of our bottle opener here. So we're gonna come up again and we're gonna do yet another 2D contour operation here. And we're gonna use the same tool, our coolant's on flood, and yet again the same spindle speed and the same feed rate here of 30 inches per minute. Now in our geometry tab, we need to come on over here and select this guy right here. And you notice once again that whole line pops up. And so let's go ahead and click there and then double click on it. And we're gonna click that guy, and that's it. We just want a blue line right here, a toolpath to come through and basically make this larger chamfer. Okay, go ahead and hit our green check mark. Okay, and then in our passes tab, once again, scroll down to make sure the chamfer box is checked, and we're going to use a chamfer tip offset now of 0.02 inches. Okay, that should do it. Let's go ahead now and hit OK. And There it is. Okay, make sure you go ahead and simulate this so it's working properly for you. And also check to make sure the chamfer tip is down below this little lip or edge here. All right, and our next operation is going to be basically a deburring operation. We want to remove any jagged, sharp metal edges on this edge in particular. So to do that, we're actually going to use now a 2D milling operation as a 2D chamfer. Okay, and we're going to stick with our tool, our 1/4 inch 45-degree chamfer end mill that we've been using. Our coolant is on flood. Same thing here as well. 3,000 RPMs and a cutting feed rate of 30. Okay, for our geometry, we're just going to select that front edge that we want to deburr. And now for the passes tab, okay, for our chamfer width, we want to use a chamfer width of 0.008 inches, a chamfer tip offset of 0.08 inches, and then finally a chamfer clearance. The default value here we'll go ahead and use of 0.025 inches. Let's go ahead and select OK. And if you did it all right, you should end up with the following toolpath here. Okay, as always, go ahead now and please simulate every operation when you're done to make sure it's done correctly. All right, now it's time to start our last and final operation here. So our last and final operation involves a unique tool, and what we're going to do is we're going to remove the material right underneath our lip here. To do this, we're going to do a 2D contour operation. So go ahead and click on 2D contour. We need to change our tool now, and what we need to do is select a unique tool in our library. Let's see here, our bottle opener library, and it's called a key seat or slot mill. Okay, and what this is going to do, it's going to come underneath our lip and remove material. So let's go ahead and select that guy. Okay, we're going to set our coolant to flood. We're going to use a spindle speed of 4,000, and then we're going to use a feed rate now of 20. Okay, so spindle speed of 4,000 and a cutting feed rate of 20. So we're going to slow it down a little bit more than our previous operations. Okay, now for our geometry, okay, let's see here. We're going to check right here, and then we're going to check stock contours. We're going to rotate our part so we can click this underside of our lip here, right there. Okay, so you should have a geometry that looks something like that. Okay, now heights tab. This is important, so please listen. So for our top height, we're going to come down here and we're going to use selection, and we're going to select that same face we just clicked right there. And then we're going to offset it. We're going to move it down here a distance of minus, so we're going to move it down 0.22 inches. Okay, hit enter. Okay, now we're almost done here. We need to do our bottom height, and we're going to do a selection again, and we're going to select that flat surface right there. And we're going to offset that, okay, a very small amount, a distance of 0.001. So we're going to move it up just a hair so our tool doesn't crash into that flat surface. All right. Okay, now for our passes tab. What we're going to do now is we're going to check multiple finishing passes. We're going to set our number of finishing passes to 2, and we're going to use a step over of 0.06 inches. Okay. And then we're going to scroll down here to multiple depths. And for the maximum roughing step down, and for our finishing step down, we're going to use the same value here of 0.06. Same thing here, 0.06. Okay, and for our finishing step downs, we're just going to keep our value here of 0. Should be 0. Okay, and then finally on our linking tab, we're just going to check this box right here that says keep tool down, and then everything else should be good to go. Let's go ahead now and hit OK. And if you did everything right, you should get the following tool path here. All right, and make sure you simulate that. But now that we're done with everything, we're going to go ahead now and simulate the whole process. So click on Setup 1, click on Simulate, get a good isometric 3D view here while you simulate it, and then click on Show Stock. And for colorization, we're going to go with Use Material, our aluminum here, and you can change it if you want to a different material, your call. And then so let's go ahead and play it, and I'm going to speed it up for time purposes here. So here is our roughing operations, our 3D adaptive. And please double, triple check and watch your simulation multiple times very meticulously just to make sure that everything is running smoothly. Okay, so there's our finishing jobs. We got our fillets on there and our chamfers. And finally, we got our, check this key seat cutter job out, that big chamfer right there. And then our key seat cutter coming through and removing that material under the lip. All right, when you're done, please check your machining time. If you did everything correctly, you should have an overall machining time of 13 minutes and 9 seconds, or something very, very, very close to that. Okay, and if you don't, please come talk to me and I'll help you out. All right, hope you learned something. Thanks for watching. We'll see you next time.